Hello, my name is Bill Copeland. This is the Silicon Valley Science Report. I have a lifelong interest in astronomy. I'm a member of the American Association for the Advancement of Science. I keep up on the data on astronomy from many sources, including the Science magazine in the AAAS. I read a lot of magazines and technical articles. I have a Master of Science degree in Cybernetic Systems and a Bachelor of Arts in Math. And of course, I followed all the episodes of Star Wars and Star Trek. I want the universe they describe. What do Star Trek and Star Wars say about our civilization? They show that we have a vision of a universe that doesn't limit how far and how fast we can travel. That really appeals to me. The current world model doesn't support that. And I want my Star Trek universe. I believe we can reconsider certain fundamental assumptions in our current model of the universe in such a way that we can make that universe possible. When we make new science, we use the scientific method. Sure, each science discipline has its own particular ways of describing the world. Biologists use microscopes, geologists use stereoscopes, and astronomers use telescopes. But each discipline uses the scientific method to develop scientific knowledge. What is the scientific method? I'll tell you. You start out with conventional wisdom about how something works. You might be sowing crops or pounding iron. But then the seeds don't grow. Your iron breaks. The result doesn't agree with what you were taught. How am I going to solve these problems?
Hey Ron, can I interrupt you for a second? I've been thinking a lot about this cosmology. I know there are a lot of facts out there that any new hypothesis would have to conform to make sense. I think I've got something that really works. And you, come and join my Facebook Cosmology Unlimited group.
Well, you could throw up your hands and give up on the project, or you could study the problem more intensely, more closely. To do that, you gather some data and you make up some theories that explain the data. Once you have a few theories, you test them, and all of the theories that actually fully explain the data become candidates for the correct theory. In the end, you choose the theory that is the least complex and explains the correct result. That is called the theory of Occam's razor. Now let's focus on astronomy and how our current world model, called cosmology, was developed. Astronomy has gone through many revolutions that demonstrate the scientific method. As long ago as 10,000 years, it seemed obvious that everything in the sky rotated around us. Things come up in the east, go down in the west, and they did this every day for thousands and thousands of years, of course, and it seemed intuitively obvious that that's the way the world was. Farmers, shepherds, and other people unfortunately needed a calendar they could depend on. They needed to know when to sow their crops and when to plow, etc. So people started carefully charting the sky. Good star charts prove the Earth and planets rotate around the sun. More detailed star charts identified thousands of stars we could see, and some wispy, cloudy things looked just like little unimportant objects in the sky. Up until a century ago, scientists thought all the stars we could see in the sky were the whole universe. Then, less than a century ago, a scientist discovered the stars make up one galaxy. All the stars we see are in one galaxy, and the small, cloudy, wispy things are actually other galaxies. He also discovered that there's a rough relationship between the distance of galaxies and their apparent colors. This is strange. The farther the galaxies are away, the redder they are. That was a strange concept, very counterintuitive. Suddenly, our universe got very, very big. Let's shift gears and talk about how we came to accurately describe how objects move, the field of physics. What are the forces that control the motion of things, such as planets, galaxies, wagons, and even atoms? Physicists worked out the math 200 years ago to predict the motions of electrons, wagons, etc. They showed that the harder you push a wagon or an electron, the faster it goes. We know that. We see that every day. That was okay when you tried to predict what happened when you pushed wagons, etc. Things get very strange when you're close to the speed of light. To solve that problem, the equations of relativity were developed. That happened just early in the last century. Relativity predicts the following. Say an object is traveling away from the Earth at 100,000 miles per hour, and you push hard enough to make it go 200,000 miles per hour. Oddly enough, you have to push even harder to get it to go 300,000 miles per hour. And the closer you get to the speed of light, whoosh, the harder you have to push to get another 100,000 miles per hour. You just can't push hard enough to make anything go the speed of light. This is relativity. So here's a summary of our current cosmology. We have good star charts, and we can predict the way stars, planets, and other things move, even close to the speed of light. We know that the universe is much bigger than we thought 1 century ago. And our physicists have concluded the universe started with a big bang because everything seems to be flying apart. The net effect of this cosmology is that it limits us to a small segment of the galaxy. We can't travel fast enough to get very far. Well, that's not my Star Trek universe. I want to go faster. I want to go farther. I need my space. Any spaceship I build now, according to the current laws of cosmology, will take hundreds of generations to get to another star, like Rigel Cantaris, which is over 3 light years away. That's too much time, but stay tuned. In the next episodes, I will explore alternatives to the Big Bang Theory and to relativity that might allow us to overcome these limitations. This is the Silicon Valley Science Report.